Hello everyone, welcome back to our YouTube channel Becoming a Rose Developer. I'm Desire and today we have got Eleftherios who has just completed the course Linux Basics for Robotics and he will be giving us a presentation on that. So what I'm going to do is to hand over the platform to him so he can begin his presentation. Alright, whenever you're ready Eleftherios.
Okay, thank you very much. My name is Eleftherios Petropoulos, and I will doing the presentation for the Linux Basics Robotics course. Okay, so I'm gonna start with the terminal.
Alright.
I have here the first commands that are necessary to start the robot visualizer program. I've copied them to a text file so it can be quicker.
Okay.
Okay, oh, something went wrong.
Let's give it some time. I
Oh,
think it will
okay.
show up. Okay.
Yeah, now it's okay. Okay, good.
You can drag it into focus by using shift, then pressing the right click in our face. Yeah, okay. Shift
Yeah,
drag.
okay.
You can hold shift down and then you can drag. Yeah, much
Yeah,
better. Okay.
I think I think we're okay now.
Yeah, that's fine. Let's continue.
Okay, okay. Started that. Now we're gonna execute the command that starts the teleop uh, uh, the keyboard command that it's the script that we are able to control the robot in case something goes wrong. We
Okay.
can control the robot, put it back in a certain place so we can go on from there.
Okay.
Okay, now I'm gonna start the robot interface Python program, which is, as I saw, is the main ROS program that communicates with the robot. So whatever scripts that we run, it translates them to the robot, let's say. Okay, so this is ready. Okay, and now let's open our robot, the obstacle avoider, the bash script. Okay, and now it's going to start. First, takes some measurements from the sensors that the robot has on. Some measurements from the front of the robot, the front left, the right left, and right and left sensors. So we can measure the distance that the sensors see, so we can decide which way to move, whether to go straight forward, turn left, turn right, or anything else. Okay, now that we see here in the screen that the robot is moving, now it made a left turn, checking again its parameters, and it's going to move forward. And unfortunately, it hit the obstacle.
Why do you think that is, right? Because that's a very interesting thing to discuss. Why do you think it didn't see that correctly, or the camera struggled to?
Uh, yeah, as I see from the parameters, I believe that maybe is something I didn't write correctly in the program, maybe for because
Not really. Not really.
or maybe the sensor didn't quite see exactly the obstacle on the front left sensor.
All right. I would
It's
check
either
that
that
definitely,
or I
but
didn't.
it's not anything to do with your code because we can see right now it managed to stop and it avoided the first time it saw that obstacle, it avoided it, but from a different side there was a struggle. So it's a very interesting concept. We'll talk about it
Yeah.
later.
Okay.
And
Okay.
let's
Good.
see, is your
And
step-by-step script
also,
running as well?
yeah, I will.
Okay,
I'm.
okay. Let's have it
Oh,
running so we can
okay.
see.
I have to. Yeah, I have to provide the permissions, the execute permission for the bot
Mm-hmm.
bus. Okay, I believe now it's yes. Okay, perfect. Basically, every bus has a read and write permissions, and in order to execute a bus script, we have to give it executing permissions
Mm-hmm.
for the users and the admin. And now we see it that it is running. So basically, what this does is it takes data from the robot functions bus,
Mm-hmm.
and that gets its data from the robot interface,
Mm-hmm.
and it shows us here in the terminal some data. For example, the angular velocity in three different types: the x velocity, the y, and z, and the same it gives us the linear acceleration
Mm-hmm.
and the position of the robot in real time based on x, y, and z.
Mm-hmm. Mm-hmm. Okay.
Okay, so we see it here running, and here the robot, the obstacle avoider is still running, and luckily, as we see, it hasn't hit any other obstacles so far.
Mm-hmm. Yeah. All right. So we can
Okay.
maybe stop execution here for the obstacle avoider, and let's go through the code. Right. So take us step by step. If you have any slides, you can use them for explanation. But no worries. Whichever
Okay.
method you prefer.
Okay. Should we stop the real robot or
Yes. Yes. Stop the
leave
real
it
robot.
up? Okay, disconnect. Let me disconnect. Okay. 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 Now here we see the bus script for the obstacle avoider.
Mm-hmm.
Uh, okay, so the most part I took it from the courses from the notebook,
Mm-hmm.
and then I modified it. Okay, one thing I saw the first two times I ran the script is that the Angular the how forgot the word, sorry. um, when in the code in the script we want the robot to check for the sensors to see if for example if to check the front left sensor
Mm-hmm.
or the and the front sensor and the front right sensor, and if the front left sensor the obstacles are less than some distance, then to the robot shall turn right. And what I saw was we used to the robot turned too much left or too much to the right,
Mm-hmm.
and if it was in a corner, for example, it would turn from obstacle to obstacle,
Mm-hmm.
and it couldn't find a way out.
Mm-hmm.
Or another problem I came upon was, for some reason, maybe it was my fault, I don't know. Um, my Once I ran it the second time, my robot kept going on a circle. It it was stationed at a point.
Mm-hmm.
It just kept turning right, turning right again and again without ever moving forward.
And how did you deal with that?
Uh, I checked the code again, and I saw that I had a problem with the code. I typed something wrong, so it kept just turning right. So it
Mm-hmm.
was my fault. It was something I typed wrong in the code. Okay, so let's say about the scripts here. Um, Here in the first part, we define some functions, the turn right brief and the turn left brief,
Mm-hmm.
that we use them later in the while loop. Um, what we do here is once later in when it checks, for example, if it has an obstacle to the front and to the left, we tell it to turn right. So uh, we use this function, so it turns to the right for minus 0.5, and the same for the left.
Mm-hmm. Can you tell us a bit more what's
So
happening in those functions, right? So why do you need the sleep time there?
for it for the robot needs some time to turn.
Mm. Okay. Okay.
So what we're doing is we're giving it some time for the robot to turn, and then set the CMD, the velocity, the angular velocity again back to zero.
Mm-hmm. Mm-hmm. And how did you choose point three?
Sorry, the sleep point three.
Yes. How did you choose that time? Why that?
Um, um, I don't actually remember it at the moment. Sorry,
Yeah, because
I'm not sure now at the
so
moment. Sorry.
the idea is that whatever parameters you use, right, they are as a result of a set some reason, right? So there
Yes,
needs
of
to be
course,
a valid
of
reason
course,
to
of course.
say I want it to turn for zero point 0.3 seconds at zero point 0.5 meters per second, or I mean radians per second, right? So I want
Yeah.
to understand what was the reasoning behind that. I remember you speaking about it
Uh,
obtaining more than you liked. How did you
yeah.
deal with that?
Yeah, so here, I believe this is the part, I think. So this this here, the zero point 0.5 is the velocity of at which the robot will turn
Mm-hmm.
when we say when we tell it to turn. So this the zero point 0.3, yeah, now I remember, is if I remember correctly, is the amount of time for which the robot will turn
Mm-hmm. Mm-hmm.
at the velocity that we gave it. So, if I remember correctly, now this one was supposed to be 0.5, 0.8 at the program given to us in the notebook.
Yeah.
And that was, like I told you before, I thought it was too much.
Mm-hmm.
And so I shortened it to zero point 0.3, so it should turn less.
Mm-hmm. Okay. All right. Makes sense.
Okay. Should I continue down to the
Yes.
rest of the script?
Yes. Yes.
Okay. Okay. So now we execute a while loop where we get the five seconds
All right, Petros. Can you hear me?
the sensors.
Okay, I think I lost you for a sec there, Petropoulos.
Oh, do you hear me now? Everything okay?
Yeah, now it's better.
Oh, okay, good. So as I was saying, we get the 5 different ranges from our robot sensors,
Mm-hmm.
as we can see here, and then we check 3 different. Uh, we check the 3 different ranges for the distance,
Mm-hmm. Why three?
and then
Sorry.
we have some. Yeah, sorry.
So why three? Why three indexes? Can you take me through the logic behind that?
Y3.
Yes. Why did you
And
choose
you
to
mean
consider only three indexes? Why not two? Why not one? Why not five?
uh, I believe that 3 is the needed amount, because if we, for example, check only one, we wouldn't have enough data to give to the robot for it to decide where to go.
Mm-hmm.
And for its conditions, for each condition, we use of script, as we will see later. We need more than one range, so we can decide which way to go.
Mm-hmm. Mm-hmm.
So, and I believe 5 would be too much, and it will be too hard on the robot, and I believe it will be too much of code. 5 different ranges. For example, if we used left, front, right, and right,
Mm-hmm.
I believe it would be too much. So 3, I believe it's the best option
Yeah. Okay.
for this. And as we see here, now we're starting to provide our conditions uh, with which the robot um, will move, depending on. Let me make this here, okay. And depending on where it will find the biggest distance
Mm-hmm.
from the obstacles, and it will um, turn either left or right, or keep moving forward, depending on the distance between the obstacles that it has around it.
Mm-hmm.
For example,
When you say the biggest,
yeah, yeah.
what do you mean? Do you have any criteria to determine how big the obstacle is, or if just one index says it's
Not
going to be this big?
sorry, not the size of the obstacle. I'm sorry, the distance
Okay. Okay.
of between the robot and the obstacle.
Okay.
I'm
Okay.
sorry.
Okay.
It doesn't matter if the obstacle is small or large.
Okay.
We just want to avoid it.
Mm-hmm.
Okay. So, for example, here we see that we check the front left, uh, the front left, and if we see the front left, if it's 0, and if it's not free, if the front left is not free and the front is not free, and the front right is not free, then we decided to tell the robot to turn left.
Mm-hmm.
Or if and it will turn left. I'm sorry, if we see that the left range is more than the right range, it will turn left. Or if it is the opposite, the right range is bigger, sorry, than the left range, then it will turn right.
Mm-hmm. Mm-hmm.
Okay. Or if we see, like here, we see that the left and right are equal, then it doesn't turn at all. And then we have similar conditions where we check again if we have, for example, here front left is not free, the front is not free, and then the front right is free. Then we tell the robot to turn right.
Mm-hmm. Mm-hmm.
And it
Okay,
keeps
so
going on
let's
to the
the
end. Yeah.
the criteria is very much the same, right, for each case that you're considering, right? So let's look
Yeah.
through. There is line. I think for this case it's line 126 to 127 there, right? So I
No.
want you
Here.
to
Yeah.
tell me what is going on in the calculation of the time to move, right? So can you explain what's going on there and why do you need to remove a 1 second, for example? Yes.
Now, here we set the distance to move,
Mm-hmm.
and what it does is it from the front it scans the front range.
Mm-hmm.
Okay, so we get uh, we get some meters here, and we have a threshold, uh, and we define that here. This is the distance threshold that we want.
Yes.
This is the minimum that we want for our robot to be near an obstacle.
Yes.
We don't want it to be uh, closer than zero point 0.3.
Mm-hmm.
So let me go back again. Sorry. What we do here is what we wanted to do is uh, move for this range. So what we do is we don't go forward very much. We do it step by step in order for to, I think, believe to give the robot time to scan again and avoid as much as we can hitting obstacles. And
Okay.
here is what we calculate the time that the robot moves from the distance to move that we define here with zero point 0.1 meters and per second. Sorry,
Mm-hmm.
um, and here uh, we know that for we have a delay for the scanner to, if I remember correctly, that we have the scanners need some time to get the range again, so we give it some time for it to uh, some delay, so we can get the scanners, so the scanners can get the data again,
Mm-hmm. So
if I
it's
remember
basically to
correctly.
protect the robot from colliding in case data comes late, right?
Yes, yes, yes.
Mm-hmm.
And
All right.
it's here it equals to the terminal, the distance it moves and time that it moves.
Mm-hmm. Mm-hmm. All right. All right. Thank you very much, Lefteris, and thank you so much for a wonderful presentation. So what we'll do is we'll wrap it up here, and then we'll finish it up in the next
Okay. Yes.
All right, everyone. This was Lefteri's presentation, and I'd like to encourage all those of you who want to try this course or for any other ones that we offer certification on to do so. And then you can also come and showcase your work and help us understand your approach to solving the problem. Until next time, keep pushing your learning.